We now discuss the solution of a problem from the section three-dimensional geometry, and the problem is related to the line and planes, and this question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is, if two distinct points Q, R lie on the line of intersection of the planes minus x plus 2y minus z is equal to 0 and 3x minus 5y plus 2z is equal to 0, and PQ is equal to PR is equal to under the square root of 18, where P is the point with the coordinates 1, minus 2, 3. Then the area of the triangle PQR is equal to, we are given four options, option A, option B, option C, option D. We have two planes. The first plane is minus x plus 2y minus z is equal to 0, and the second plane is 3x minus 5y plus 2z is equal to 0. And we are given two distinct points Q and R that lie on the line of intersection of these two planes, and P is given to be a point with coordinates 1, minus 2, 3, and further given PQ is equal to PR is equal to under the square root of 18, required to find the area of the triangle so formed, that is PQR is equal to. We are given Q, R are 2 points, Q not equal to R, that means they are distinct, and it is given to be they lie on the line of intersection of these two planes. And this is the line of intersection of the two planes, the planes we have not shown. Okay. And on it, Q and R are two distinct points. Agreed. And this implies QR is the line which is the intersection of these two planes. So QR is the line of intersection of the given two planes. Notice that, look at these two equations of the planes, and if you take a point K, K, substitute in the first and second equation, these points for each K belongs to R satisfy both these equations. That means the points with coordinates K, where K is arbitrary belongs to R, lie on the line of intersection QR. Agreed. That means the equation of QR, that's the line of intersection of the planes, because K, K is on R, is on QR for every K belongs to R. So the equation of the QR is X is equal to Y is equal to Z. That is X minus 0 by 1 is equal to Y minus 0 by 1, Z minus 0 by 1. We view it like this. What is this? It is the symmetric form of a straight line passing through the origin 0, 0, with direction ratios 1, 1, 1. That's right. Now, we are given a point P whose coordinates are 1, minus 2, 3, and PQ is equal to PR is equal to 18 under the square root of 18. That means the distance between P and Q is equal to the distance between P and R is equal to root 18. Let's look at it. P, this is the point P, and PQ root 18, PR is root 18. Thus we have obtained a triangle, and these two sides are equal. Therefore, PQR is an equilateral is an isosceles triangle. Yeah, that much only we can say. It's an isosceles triangle. Agreed. Now we continue in the next slide. That's what we have so far. And let's now drop a perpendicular from P onto QR. Call it as PM. So PM is let PM be the perpendicular drawn from P on QR. So this is the one. This is the point M. Now what this PM will do? PM will bisect QR. Bisect QR because it is an isosceles triangle. It is the altitude that we have dropped from the vertex P. It bisects the base. That is. So then QM is equal to MR. Why? Because PQR is an isosceles triangle. Now we have the triangle, we have the base, we have the altitude. Therefore, the area of the triangle PQR is half base, that is QR, into the altitude height, that is PM. But QR is 2 times QM because M is the midpoint. So that will be 1 by 2 into QR is 2 times QM into PM. So 2 cancels and this is QM into PM. So so if you know the length of the altitude and the length QM, if you know, the area of the triangle PQR can be found. So the problem now reduces to find the lengths PM and QM. Now let the coordinates of M be, so M is on QR and any point on QR is K comma K comma K. So therefore the coordinates of M be alpha comma for some alpha belongs to R because M lies on QR, right? Now this is alpha comma alpha. Now PM is the line joining the 2 points 1 comma minus 2 comma 3 and alpha comma alpha. So the direction ratios of PM is alpha minus 1 comma alpha minus of minus 2, alpha plus 2 comma alpha minus 3. They are the direction ratios of PM, right? So note that the direction ratios of PM are alpha minus 1 comma alpha plus 2 comma alpha minus 3. And remember the direction ratios of QR are 1 comma 1 comma 1. And now PM is perpendicular to QR and PM has direction ratios alpha minus 1, alpha plus 2, alpha minus 3. QR has direction ratios 1 comma 1 comma 1. PM is perpendicular to QM will imply the product of the direction ratios and sum it up, that will be equal to 0. Alpha minus 1 into 1 plus alpha plus 2 into 1 plus alpha minus 3 into 1 is equal to 0. Now simplifying, we will get 3 alpha is equal to 2. That will imply alpha is equal to 2 by 3. So the coordinates of M, thus we got, that is M 2 by 3, 2 by 3, 2 by 3. Thus M is given by with coordinates 2 by 3 comma 2 by 3 comma 2 by 3. Now it's easy now. We can find out PM and QM and the area can be found. And that we do it in the next slide. Agreed. That's what we have. Now the coordinates of P are known, the coordinates of M are known. So PM square, PM or the length PM is the distance formula used. So the PM is under the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So 1 minus 2, 3, 2 by 3, 2 by 3, 2 by 3. So this is the distance formula. Now simplify. This is the simplification what we have done, further simplification, and ultimately we got after cancelling 3, both numerator and denominator, you will get under the square root of 38 by 3. So PM, the altitude we have obtained, and QM, to find QM, what we do is we use Pythagoras theorem. And for that we consider the right angle triangle PQM, and then the length of the hypotenuse PQ square is equal to QM square plus PM square. And if you want QM square, then it will be PQ square minus PM square. So in right angled triangle PQM, we have QM square is equal to PQ square hypotenuse square minus PM square. And PQ square, PQ is given to be root 18. So PQ square is 18 minus PM square, just now we have calculated, it is the PM is under the square root of 38 by 3, PM square is 38 by 3. Take the LCM and simplify, we will get 16 by 3. Therefore, QM is equal to 4 by root 3. Right. So the area of the triangle, we have already done it. Let's look at the equation 1. So the area of the triangle PQR is QM into PM. So QM is 4 by root 3, PM is under the square root of 38 by 3, and this is equal to 4 by 3 multiplied by under the square root of 38. So that is the area of the triangle. Let's look at our options. Our answer 4 by 3 under the square root of 38 appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the problem from the section 3-dimensional geometry, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.